we discuss here Laplace transform. Again, in Laplace transform, if we inverse Laplace transform, if we know Laplace transform, then this is very easy to discuss inverse Laplace. Now here, up till now, we have converted our signal from time domain to frequency domain. That means f of s under Laplace transform. Okay. Taking Laplace transform, we have converted our signal from time domain to frequency. Now we have to convert this data from frequency domain to time domain. Here we have to use inverse. Mathematically, we can denote here. This is a Laplace transform of this function f of t is equal to f of s. Then this is a Laplace transform, and if I will take L inverse and operating on this frequency domain, then we are getting this function f of t. And this is called inverse Laplace transform. Okay, this is inverse Laplace transform. Now, to solve problems and to work on this inverse Laplace transform, this is very easy because we are knowing Laplace transform. Now I will recall some these standard result and then we'll go towards some problems on this Laplace transform. Now tell me first of all Laplace transform and then we'll find its inverse of this Laplace. Now Laplace transform of 1. What is Laplace transform of 1? Is 1 by s. Then I will write here L inverse of 1 by s is nothing but 1. Laplace transform of, I'll write in general t raised to power n. Then what is Laplace transform of t raised to power n? This is n factorial, or you can write in terms of gamma again, s raised to power n plus 1. Then most of the time this formula is stated in this way. L inverse of 1 divided by s raised to power n plus 1. Now to write this formula, we are knowing this is our standard result. Should have here n factorial as a numerator, and this is constant term. N factorial not here, therefore we have to multiply by 1 upon n factorial, and here multiplying by n factorial. Then we'll write here 1 divided by n factorial, I will multiply, and this total term is nothing but Laplace transform of inverse Laplace transform for t raised to power n. Then the standard result for this Laplace transform of e raised to power at. What is Laplace transform of e raised to power at? 1 divided by s minus or ROC is again there. The inverse Laplace transform for 1 divided by s minus a is nothing but e raised to power at. I will write same in this. I will write same formula. L inverse of Laplace transform of e raised to power minus 80 is equal to 1 divided by s plus a. Then here L inverse of 1 divided by s plus a is nothing but e raised to power minus a. Again, keep in mind, if we know Laplace transform very well, then easily we can find inverse Laplace transform. Then here I will write here Laplace transform for sine function, sine of at. Laplace transform sine of at is a divided by s square plus a square. Then we can write L inverse of 1 divided by s square plus a square. Now here is a square, we should have here a square, but a is not here, this is only 1. Therefore, we have to take adjustment of this constant a, multiplying by this constant a here and dividing by this constant a. Therefore, this is sine of a. Now, similar way we can write Laplace transform of cos at is equal to a divided by, sorry, this is s divided by s square plus e square. From this we get L inverse of s divided by s square plus e square, which is equal to 1 divided by, sorry, this is equal to cos of theta. Now, for this hyperbolic function, Laplace transform of sine hyperbolic 80 is equal to a divided by s square minus a square. Therefore, we can write L inverse of 1 divided by s square minus a square is equal to 1 divided by a into sine hyperbolic. Okay. Means here, if we know standard results of this Laplace transform, then we can find easily inverse Laplace transform. I will write here last formula for this cos of 80 is equal to a divided by, sorry, this is s divided by s square minus a square. Then here inverse Laplace transform of s divided by s square minus a square is nothing but cos hyperbolic. Okay. Now I will cover some examples and then we'll go to some examples from properties which we are knowing from Laplace transform, and then using that same property we'll solve problems on this inverse Laplace transform. We'll solve some example. Find inverse Laplace transform of the following. Or I will write here in this way also. L inverse of 1 divided by s square minus 9. What will be answer? Actually, this is formula for sine function. We are knowing this is sine hyperbolic or sine function. This is sine function. This is a divided by square. Sorry, this is minus inside. This is minus inside. That's why we are doing hyperbolic. Ah, to write this, I will make the adjustment because we should have this adjustment to find Laplace transform this function. Okay. What we have to do here? We have to adjust plus 3 square minus 3 square, and I will multiply by 3. Means I am adjusting here 3. And this is nothing but 1 by 3 into sine hyperbolic of 3. This is inverse Laplace. And second, we have to find L inverse of 1 divided by S minus 2. We are knowing formula. Laplace transform for e raised to power at is equal to 1 divided by S minus a. From this we are getting this is the Laplace transform e raised to power 2t directly. The third one, we have to find L inverse of, now I will write this formula, L inverse of 1 divided by 1 divided by s square plus 25. What would be the answer for this? We have to find L inverse of this term. This is again here, I will write here is L inverse of, this is in terms of sine because numerator considering constant and this is a square plus 25, then surely this is for sine. I will write here this as 5 divided by s square plus 5 square Now I am multiplying by 5, therefore we have to divide by 5. This is nothing but 1 by 5 into sine of 5t. Suppose I will write,
सर
yes.
आपण डायरेक्टली फॉर्म्युल्यानुसार नाही लिहू शकत का?
Here, याचा answer directly.
हां सर, एल इनवर्स 1/s² + 25 आहे ना, त्याचा आपण डायरेक्टली 1/5 साइन 5t लिहू शकतो ना?
Yes, yes, we can write, but this is the beginning. That's why I am writing step by step. Yes,
ओके सर.
directly we can write. Do not worry. This is in the
ओके
beginning part. That's why I am writing here. Otherwise, you can write
ओके सर.
here. We have to find L inverse of 1 divided by S cube. Okay, we have to find inverse Laplace transform for this function. Again, here keep in mind, I will try to write Laplace transform for t raised to power n. Because if t raised to power n is there, then we can write n factorial divided by s raised to power n plus. We have to follow, we have to use this formula. Now again here, if divided by n plus 1 term is there, then we have to take factorial of n only. Here is n plus 1 is 3. That means here we have to take 2 factorial. Okay, this is 2 factorial should be there here. 2 factorial should be there. I will write here in this way. L inverse of 2 factorial divided by s raised to power 3, and if 2 factorial we are taking, therefore we have to divide by 2 factorial, and this is nothing but 1 divided by 2 factorial is 2, and if power is 3 here, then this is t square, then this is Laplace transform t square. We can write t square divided by 2. In similar way, I will write here in this, I will write here L inverse of 1 divided by s raised to power 4. Then what we have to do? You can write directly t cube into, we have to multiply by 3 factorial, or you can write t cube divided by 6. Okay, in this way you can say, if you are getting this idea, you can write directly also, doesn't matter. Suppose I write now next, we have to find L inverse of s plus 1 divided by s square plus 9. We have to find L inverse of this term. Again here there is no such formula for this, but inverse again showing its linearity. That's why I will use here L inverse of s divided by s square plus 9 plus L inverse of 1 divided by s square plus 9. This is equal to inverse Laplace transform of this function is cos of 3t plus, now I will write here directly. This is 1 by 3 into sine. This is your inverse Laplace transform. Are you following here? I am taking here, this is multiplied by 3, I divided by 2, and you will get here that.
Yes sir.
Next, we have to write, we have to find out inverse Laplace transform of, now tell me what will be inverse Laplace transform of this function. L inverse of, L inverse of 1 divided by s minus a whole square plus 1. We'll write okay, 1 I will write. Before this, I will state this formula and then you can tell me about this. This is Laplace transform of e raised to power at into sine t. We are knowing this is our property. Here we have to write, actually this property is here. E raised to power at into f of t. This is f of s, and we have to make a change in s, s minus a. Therefore, this is f of s minus a. Now here, if silently I will write this formula here in this way. Suppose this problem is given and stated in this way. L inverse of 1 divided by s square plus 1. Yes, surely we are getting its answer. Is a sine t. But here, s is changed. S is changed by s minus a. S is changed by s minus a. Therefore, surely our time domain function that should be multiplied by e raised to power 80, because this is as per our property. Okay, we are knowing this shifting property. From this shifting property, e raised to power at term is there, and this is multiplied by e raised to power at. That means I will write here e raised to power at, and then remaining term is nothing but 1 divided by s square plus. If we are multiplying by e raised to at, then this s minus a we can take outside, and directly I will write here only s square, and this is nothing but e raised to power at into sine. Are you following here? In the same way, I will write this example. In similar manner, I will write this example. L inverse of s divided by s minus 3 square plus 60. Now, how to solve this example? Now, again here, we can use this property. This property. We can use this property. But here, while using this property, whatever it may be on our this frequency domain in Laplace transform function, all s should be replaced by s minus a. All s should be replaced by s minus a. Now here numerator is, s is there, and this is only s. This is not like s minus 3. Here is s minus 3. Therefore again I will make adjustment. L inverse of s minus 3 I will write. I will write plus 3 divided by s minus 3 whole square plus 16. 16 means I will write here 4 square. This is equal to, I will use again linearity property of this inverse Laplace transform. And this is s minus 3 divided by s minus 3 whole square plus 16 or 4 square plus L inverse of L inverse of is 3 divided by, or otherwise I can take 3 common also. 3 divided by 1 divided by s minus 3 whole square plus 4 square. Okay. Now I will apply this property. If suppose our this frequency domain function change in s by s minus 3 is here, s minus 3 is there. Therefore, I will take e raised to power 3t outside into. Now remaining function is like here s divided by s square plus 4. Shall I will add here one step till now, and after that I will directly write s divided by s square plus 4 square plus 3 into e raised to power 3t L inverse of 1 divided by s square plus 4 square. This is equal to e raised to power 3t into, this is a Laplace transform of cos of 4t plus 3 into e raised to power 3t into, now here this is for sine, but here should be 4. 4 is not there, therefore I will multiply by 4 into sine of 4t. Sine of 4t. You can write here in this way. E raised to power 3t into cos of 4t plus 3 by 4 into e raised to power 3t into sine of 4. This is your L inverse of s divided by s minus 3 whole square plus 60. Okay, this is inverse Laplace transform for this function. Okay. And again, I will write here another result, another examples. Again, 5, 6, 7, 7. We'll find inverse Laplace transform of, and tell me what will be our answer. Inverse Laplace transform of 1 divided by s plus 3 whole square minus 4. Now what will be answer? Orally also you can write answer. Do not worry. Directly first. Here should be s. Here is instead of s minus 3 only s square is there. Then we can write our answer. But here s plus 3 is there. That means we have to take e raised to power 3t as common. The remaining term is 1 divided by s square minus 4. Laplace transform is in terms of sine hyperbolic, and in numerator that should be 2. Therefore, I will multiply that. And here is a sine hyperbolic of this is 1 by 2 into e raised to power minus 3t into sine hyperbolic of 2t. Got it? This is your Laplace transform. Yeah, sorry, inverse Laplace transform. This function means here this is in S domain. This is function of f of s. L inverse of this function f of s, and we are getting this is function in terms of t time domain f of t. This is inverse Laplace transform. Now here I will go towards next result to find inverse Laplace transform. You will get here formulation of this. Find inverse Laplace transform this s square plus 2s plus 6 divided by s cube. Now how to find Laplace transform inverse? I will find here again s cube is there. There is no such formula. Therefore, I will divide by this s cube to each and every term from this numerator. And here this becomes 1 by s plus 2 divided by s square plus 6 divided by s cube. I will take inverse Laplace transform separately, and then we can find here L inverse of 1 by s plus 2 into L inverse of 1 by s square plus 6 into L inverse of 1 by s cube. Now again, I will recall this formula. Laplace transform of t raised to power n is equal to n factorial divided by s raised to power n. This is, we are knowing this is standard result for Laplace transform 1 plus 2 into here should be 2. Directly we can write here because 2 is already here. Okay. Therefore, I will drop this and I will write here this plus this is sorry, this is squared. This is squared and this is cube. This is t only, and I will write here 2 as it is. Plus here is 6 and here should be 2. Here should be, now you can adjust here, write down 2 divided by 2 doesn't matter. Here 6 I will write here 1 by 2 into this. Therefore we are getting final answer as 2t plus 3 into t square. This is your inverse
सर
Laplace. Huh.
टी स्क्वेअर येईल ना तिथे
Uh, hi, here na
नाही सर 2t तिथे लिहिलंय तिथे
2t here here we are dividing by s cube. Therefore this is 1 by s. This is 2 by s square by s square. Here is s square. Now here, see here, numerator goes on increasing s plus 1. Therefore, if s plus 1 is there, then here is only n. N plus 1. Here is only n. If power is 2, then t surely containing power less than 1. Here is 1. We should go to this one. Laplace transform of t raised to power n is equal to n factorial divided by s raised to power n plus 1. Here it may be power of this s. Surely the t containing power less than 1. N plus 1 is here. Here is n. Here is 2. And here
ओके
should
सर
be 2. Okay.
ओके सर
Or otherwise, if we are not getting clearly, then find out inverse Laplace transform for 1 divided by s cube, inverse Laplace transform for 1 divided by s raised to power 6, inverse Laplace transform 1 divided by s raised to power 10. Try to solve this. Then this idea will be clear easily. Okay? Practice it on this.
यस सर
Next, 9. Okay, so we have covered this. Again, you can practice on and try to solve this example and tell me answer. Inverse of s plus 2 divided by s plus 2 square plus 20. Orally tell me answer. S plus 2 is here. Surely we have to multiply by exponential of 2t. If I am multiplying by exponent here, s plus 2 and here is also s plus 2. Same increment is there. Therefore, I will multiply by e raised to. Now remaining term is s divided by s square plus 25. Means this is cos of 5. And if I will change this problem little bit, same example, I will change in this way. S plus 3 divided by s plus 2 whole square plus 25. Then answer goes on change. Then we can write here. Here is s plus 2 and here is s plus 3. Then increment should be s plus 2 here also. Therefore, I will write here L inverse of s plus 2. I will make adjustment. Plus 1 whole divided by s plus 2 whole square plus I will write 5 square. Now, L inverse of s plus 2 divided by s square plus s plus 2 whole square plus 5 square plus L inverse of 1 divided by s plus 2 whole square plus 5 square. Again here, this is for sine. Okay, this is for sine. Here should be 5. Here should be 5. Therefore, we have to multiply and divide by this. Again, I will take this 2 outside. For that, we have to multiply by minus 2t into remaining term is the cos of 5t plus we have to multiply by 5 and divide by 5 into e raised to power 2 minus 2t term into this is sine of 5. Okay, sine of 5. Means in same example, this example and or this example, if I change this little bit, I will make a change, then you will get your time domain answer in this one. Okay. Now here, these are the straightforward result. Suppose if we have our example in this way, and then what will be our answer for this? I will write here this property. I will recall this property, and I will recall this property. What is the Laplace transform of integration 0 to t f of t into t? Laplace transform integration 0 to t f of t into dt. This is f of s divided by s. You are knowing this property. F of s divided by s. Therefore, in similar way, I will state this property L inverse of f of s divided by s is nothing but integration 0 to t f of t into dt. Again, here I am requesting that you do not go through inverse property. You should go through Laplace transform only and all properties. Try to solve each and every problem on this. Therefore, you can easily recall these inverse properties. Again, here sometimes what is happening, but again, I am not going through this in this way, but I will write here this example. Suppose we have to find out inverse Laplace transform 1 divided by s into s plus 2. Suppose we have to find inverse Laplace transform of this function. Again here, this function is not directly in any formula. We will not apply any formula. Therefore, we have to use this property L inverse of f of s divided by s. Here, what is our f of s? Is 1 divided by s plus 2 is our f of s. If this is our f of s, then what will be corresponding f of t? E raised to power minus 2t. Okay, this is e raised to power minus 2t. Then we are knowing if this formula is there, f of s divided by s, then we can write this as integration 0 to t into f of t into dt. Now, in this example, what is our f of t? Integration 0 to t into e raised to power minus 2t into t. e raised to minus 2t into dt. This is equal to integration e raised to minus 2t divided by minus 2 between limit 0 to t. This is equal to minus e raised to power minus 2 minus e raised to power 0 is 1. And we are getting answer as 1 by 2 minus, here 1 by 2 to 1 minus e raised to power minus. This is your inverse Laplace transform of this function. 1 divided by s into s plus 2. Okay. Now, for this method, we should know this formula. For this method, we should know this formula. This is our example. L inverse of 1 divided by s into s plus 2. Why I am taking this? Because sometimes this happens in, if this problem is there in our exam and if we are not recalling that formula, then this becomes difficult to solve this. Here, suppose this is our expression 1 divided by s into s plus 2. Shall we write this expression in this way? A divided by s plus b divided by s minus, sorry, s plus 2 in this form. And uh, this is called uh, we are using here. Uh, and now this becomes very easy to find out inverse Laplace transform of this. You are knowing here, if these factors are there, then we can write here factors in this way. L inverse of, then we have to find L inverse of this function, find out L inverse of this function, and this is already we are getting A into inverse transform of this is 1 plus B into inverse of this to minus 2. Okay, an answer. यही है answer हमारा. Only what is our duty? Our duty is to find values of A and B. And we are knowing that how to find out these values of A. Okay, let us will try to find out these values of A. Here we have this expression 1 divided by s into s plus 2. These are the two factors. Therefore, we are knowing how to separate these two factors. Plus b divided by s plus 2. Now I will take cross multiplication, or by taking LCM, you'll get here. This is s into s plus 2. This is a into s plus 2 plus b into s. Now here this is our function 1 divided by s into s plus 2. Here this is numerator, this is denominator. This denominator is same. Therefore 1 is equal to a into s plus 2 plus b into s. Now if I will put s equal to 0, then what will happen? 1 is equal to a into 0 plus 2. This gives a equal to 1 by 2. We are getting value of this constant a equal to 1 by 2. In similar way, if I will put s is equal to minus 2, then we get 1 is equal to, this becomes 0 plus b into 2, sorry, minus 2. This gives b is equal to minus 1 by 2. This gives b is equal to minus 1. I'll put this value of a and b. Suppose I will write this equation as star equation. I'm putting these values in equation star, or directly we have calculated inverse transform of this. Here. This is your inverse transform in terms of a and b. We can put values of a and b here. A is 1 by 2 here. If we are following this result, comparing this, a is constant, a is 1 by 2, and b is here minus 1 by 2. Yes, we are getting the sense. Means in this way also we can find our answer. Okay? And this is a very popular way to find out inverse Laplace transform. A number of times we can find inverse Laplace transform by this method, and this method is called partial fraction method. Okay. Okay. And again, we are knowing how to find out partial fractions. The fractions we can find here factors for. Suppose I will write here in this way. Suppose in example, how to write factors here. I will only recall you are knowing all these things. Suppose this is my function f of t divided by s minus a, s plus a. Sorry, or s minus a, s minus b I will write. Okay. Means here we are getting two factors for this denominator. Therefore, we can write this as a divided by s minus a plus b divided by s minus b. Again here, again keep in mind this f of t, degree of this is our in terms of s, I write here this f of s. This is our polynomial whose degree is less than this 2. Here degree is 2, but here degree is 1. Degree of numerator is less than degree of denominator. You are knowing all these things, only I am recalling here. Suppose my case is here in this way. Again, keep in mind every time, whatever it may be, I am writing here. This is my function f of s whose degree is less than denominator. This is s minus a, and here is term s square plus bs plus c. Suppose in this way, and we will not find factors for this. No factor exists. Okay, no factor. We will not find factors for this one. Then how to write here partial fraction? This is a divided by s minus a, because factors are here. Two factors are here. First factor and second factor. Then second is our second degree polynomial, but factors does not exist. Therefore, we can write here this as b s plus c. I am taking capital letters. This is s square plus bs plus c. This is small c. This is small c. And this is capital C. Means here this is polynomial of here this is polynomial of degree 2. Then we have to write numerator in this way of polynomial of degree less than this. Here is 2, then here is polynomial of degree 1. Okay, you are knowing how to write factors for this. Again, third case is there. Suppose this is my function f2 of s divided by s minus a into s minus b whole square. Then how to write factors for this? A divided by s minus a plus, now here factors are exist but repeated two times. Therefore, this is b divided by s minus b plus c divided by s minus b whole square. In this way, we can write factors. Note down all these things, because when we are using partial fractions, then we are using factors, how to find out partial fractions of given function in this way. Again, keep in mind this numerator function is always of degree less than this denominator function. Otherwise, we have to use actual division and then we'll find further procedure. Okay. I will take examples on this by using partial fractions and we will go ahead. Why we need this partial fraction? Because sometimes we will not able to find direct answer. We have to find, suppose, Laplace inverse Laplace transform 1 divided by s square minus 5s plus 6. We have to find inverse Laplace transform of this function. Again, here surely there is no standard formula to work on this. Okay. Then how to find out Laplace transform this function? Here I will take factors. This is L inverse of 1 divided by, what are the factors? S
2 and
minus 3. S minus 2, S minus 3. These are the factors. A ना factor इसके. और factor exist होते हैं, इसलिए we can write. Okay. Now these are the factors. These are the factors. Then we have to write these factors in this way. L inverse of, I will write here. This is two distinct factors are here. Again, degree is 1. Both factors have degree 1. Therefore, I will write here. This is A divided by S minus 2 plus b divided by s minus 3. Now, our aim is to find out values of a and b. Or I will write here inverse transform again, a into e raised to power 2t plus b into e raised to power 3t. This is your answer. And type number 1 because we have to find out the values of a and b. Our answer is over. But here, what are the values of a? We'll try to find out values of a. Now I will write here for finding values of a and b. We consider 1 divided by s square minus 2s plus 6. So 5s plus 6 is equal to a divided by, here I will write this is equal to 1 divided by s minus 2, s minus 3. This is a divided by s minus 2 plus b divided by s minus 3. Easily you can find out these factors. Therefore, directly we write here. Therefore, 1 is equal to a into s minus 3 plus b into s minus 2, or putting s equal to 2. Okay. 1 is equal to, this is a into 2 minus 3. This is minus a. From this we will get a is equal to minus 1. And put s is equal to 3. Then we get 1 is equal to, this term becomes 0. This term becomes b only. Therefore, b is equal to, this is by putting these values of a and b in equation 1, therefore equation 1 becomes a is equal to minus 1 है, b equal to 1 है, यहाँ पे put करो, you will get 1. I will write this answer here. यहाँ पे a is minus 1 means minus a raised to power 2t, b 1 है, a raised to power 3t. This is your inverse Laplace transform of this function. ठीक है? I will write here example. Next example, example 2. Here factors, okay, I will take that problem again. Suppose sometime there may be happen factors does not exist. I will write suppose this example, L inverse of 1 divided by s square plus 2s plus 2. Shall you find factors for this? What are the factors? S square plus 2s plus 2. इसके factors क्या है? We are knowing this is quadratic equation and we know
1
1 9
1. But no.
1
Sorry,
1
sir.
9 1 1
No,
9
no,
1
it's not possible. It's not possible. Your factors won't be possible.
addition should be 2 and product should be 2 again here. Will not find factors. ठीक है? Therefore ये factors नहीं निकाल सकते तो partial fraction method तो applicable नहीं है इसके लिए. Name itself containing partial fraction, जिसके fractions exist है उसके लिए हम applicable कर सकते हैं. Therefore I will write here this as in this way. S square plus 2s plus 1 plus 1. चलेगा ऐसा लिखा तो?
Yes, sir.
Yes, sir.
This is equal to
Yes.
L inverse of 1 divided by s plus 1 whole square plus 1. अब आ गया हमारे फार्मूला में. अब इधर सिर्फ s स्क्वायर रहता तो हमारा आंसर आ जाता है साइन में, लेकिन इधर s के बजाय s increment in s is there. If increment in s is there, then we have to multiply by minus t. So sin is plus sin here. Therefore I am taking minus t. बचा क्या है? L inverse of 1 divided by s square plus 1 term बचा है. This is okay. If not exist, then we have to apply this type of logic and then we can find answer. Third example, and we'll find here factors and what will be answer we'll try to check. So I will find here inverse Laplace transform of s plus 4 divided by s into s minus 1 into s square plus 4. ठीक है. Now this problem is very easy to look like. Look, if we are observing this problem, this becomes very easy to solve. Only we have to find factors here. But how to find factors?
So you can we can use this as a upon s plus a upon b
Yeah,
upon s minus 1 plus c upon s square plus
right.
4.
Right. Yes. एस स्क्वायर प्लस 4. अब यहाँ पे क्या है, ये फैक्टर है, ये फैक्टर है, और ये सेकंड डिग्री टर्म है, लेकिन इसके फैक्टर्स नहीं लिख सकते हम, बराबर है ना, क्योंकि फैक्टर
Yes, sir.
लिखेंगे तो कॉम्प्लेक्स में आएंगे. therefore I will write here a divided by s, पहला डिस्टिंक्ट फैक्टर है, प्लस b डिवाइडेड बाय s माइनस 1 डिस्टिंक्ट फैक्टर है, प्लस इसके फैक्टर्स नहीं लिख सकते, तो हमें क्या करना पड़ेगा, न्यूमेरेटर पे what is degree here, degree of this term is 2, therefore we have to write degree of this less than 2, that is 1. Means here I will write cs plus b divided by s square plus 4. Now if I will solve this, and it will find values of a, b, c, a, b, c, and d, then easily we will get here inverse Laplace, because here inverse Laplace transform, this term is orally we will find, this term is orally we will find. To find out inverse Laplace transform, I will take separately cs divided by this term and d divided by this term. Yes, our answer is 1. Only we have to find out values of a, b, c, d. We'll try to find out here. This is our LCM. S into s minus 1 s square plus 4. This is LCM. A into bracket s minus 1 s square plus 4 plus b into s into s square plus 4 plus cs plus d into, we are getting here s into s minus 1, and this is your s plus 4 divided by 4. S minus 1 into s square plus 4. This denominator get cancelled. We'll compare only to numerator. Therefore, this is s plus 4 is equal to a into s minus 1 s square plus 4 plus bs into s square plus 4 plus cs plus d into s minus 1. Which term easily we can we can convert into 0, that easy, that convert into 0 directly. Means here if we are putting s equal to 1, then this term becomes 0. I will put here s equal to 1, then what will happen, this 5 is equal to, because I'm putting here s equal to 1, 5 is equal to, this term becomes 0 plus b into, here is 1, this becomes 5 plus this term becomes 0 again. Now from this directly we will get b is equal to 1. Again I will put s equal to 0, this term becomes 0 and this total term becomes 0. Put here s equal to 0, then we will get 4 is equal to a into, this is minus 1, this is 4 plus this term becomes 0, this term becomes 0, therefore we will get a equal to minus. Now we are getting values of a and b. Now our aim is to find out values of c and d. How to find? Again here we will not convert directly this into 0. I will put any value. Suppose I will put s is equal to minus 1. Then what will happen? Here this is 3. This become 3, which is equal to s equal to minus 1 means a into minus 2. Then here this becomes 5. You can choose any value for our convenience. You can take any value, but I am taking here small values because 1 and 0 already used. That's why I am taking minus. Here this is b into, this is minus 1. The square is again here minus 1 square is plus 1 plus 5 plus here minus c, because I am putting s is equal to minus 1 plus d. Here minus 1, this becomes minus 2, which is equal. I can put value of this a is minus 1, or I will write here a into minus 10 plus b into minus 5 plus this is minus c plus d here, minus here, this is plus 2. Therefore, this becomes minus 2c plus 2d, and here is 3. Value of a is known. A is minus 1. That means this becomes 10 plus b is 1. Therefore, this is 5 minus 2c plus 2d. Here this becomes, this is here 5 minus 2c plus 2d is 3. I will take this 5 to this side, that will get here minus 2 is equal to minus 2c plus 2d. And from this we'll get one equation. We'll take 2 common, minus 1 is equal to minus c plus d. This is our one equation by putting s is equal to 1. Now put another thing, s is equal to दूसरा कुछ तो पुट करो, और इसके बजाय आपको इजी मेथड पता है तो यू कैन यूज दैट मेथड आल्सो. ओनली आवर this is equal to 6. Right. This is 6 equal to, I will put directly value of a. Value of a is minus 1. This is minus, this is 2, this is 1, this is 2 square, 4, 4 plus 4, 8, plus value of b is 1. This is 2 into 8 plus 2c plus d. I am directly putting here. This is 2 into 2 minus 1 is 1. This is equal to 6 equal to, this is minus 8, this is 16 plus 4c plus 2d. Now this is 8 plus 4c plus 2d. Here is 6. Now I will take 8 to this side. This is minus 2. This is equal to 4c plus 2d. You can take 2 common and we will get here minus 1 is equal to 2c plus d. We are getting minus 1 equal to 2c plus 2d. Yes, this is our second equation. This is our third equation, and by using 2 and 3 you can find it. Both are 2 and 3 are same here. Here minus 1 sign, that means here minus c plus d is equal to plus 2c plus d. This d get cancels. C 0 आता है क्या? C equal to 0. Then d क्या होने वाला है? And d equal to minus 1 आता है. We are putting d. We are getting all values of a, b, c. A is 1, b is minus 1, c is 0, and d. ठीक है, मैं यहाँ all a is equal to a क्या है minus 1. I am continuing this problem, but I will try. Minus 1 by s plus b is 1 by s minus 1 plus c तो 0 है plus d minus 1 divided by s square plus b. बस इसका इनवर्स निकालना. If we are taking inverse Laplace transform of this L inverse, what is our answer? This is minus 1 plus e raised to power t, here minus, we have to multiply by 2, therefore 1 by 2 into sine 2. Only what we have to do here, only factorization is important. If we are taking factors in easy way, then surely we will get answer. ठीक है?
Yes, sir.
Okay. ठीक है, we'll stop here.
Thank you, sir.
Okay, sir.
Sir,
एक मिनट.